guys, so we are finally done with circles and we are going to jump right into our next chapter, which is chapter 11, and it's all about area. We're going to skip the do now and go right into the lesson. All right, let's think about when we're finding the area of something. We know the perimeter is the outside. Now the area is the inside. And if you guys remember, way back when, from elementary school, middle school, ever since you learned about area, it was always units squared. And now, did you ever wonder why it's called units squared? The reason it's called units squared is that we're literally counting how many 1 by 1 squares fill a space. So whenever we're finding the area, we're saying, okay, well, this has, X amount of 1 by 1 square units or squares filling the space. Now, obviously, it's not realistic anytime you want to find the area of something to sit there counting the amount of squares, and then you get into fractional parts of the square and all of that good stuff. So obviously, the mathematicians came up with formulas that represent it for the different figures. So if we want to find the area of a rectangle, back in the day, you guys used to say length times width. Length times width is perfect. And if you want to stick with it, stick with length times width. In geometry, we're going to go to base times height. So area of a rectangle is b times h, where b is the length of the base and h is the height. Now remember, a height has to be made with a right angle. A height has to be made with a right angle. The area of a square, because a square is always a rectangle, we can use base times height. But if you remember, the base of a square and the height of the square are the same length. Since it's all squares, all the sides are the same length. So instead of saying base times height, we can say s for side squared. So side squared, where s is the length of one side. Okay, so let's talk about some basic properties of area. Every closed region has an area. If two closed figures are congruent, then their areas are congruent. So for example, if I told you these two figures are equal or congruent, that means they have the same area. Okay, so now we're allowed to do something, so I like to call like divide and conquer. So if we're trying to find the area of this, I can find the area of this 1, 2, 3, 4, 5. I could find the area of this pentagon, and I could find the area of this quadrilateral, and then I can add those two areas together. Okay, so remember the area is the inside. So if I find the inside of the pentagon and the inside of the quadrilateral, I can add those two areas together. Now tell me, do you think that would work for perimeter? If I wanted to find the perimeter of this figure right here, could I find the perimeter of the pentagon and the perimeter of the quadrilateral and then add them together? The answer is no. Why is it no? When we're finding the perimeter of the pentagon, we're finding the outside length plus this middle area. And then when we're finding the perimeter of the quadrilateral, we're finding the outside length plus this middle area. Now the perimeter is just the outside. When they're combined, that middle shouldn't be counted at all, and it's actually counted twice. So that would not work. So it works for area, it does not work for perimeter. All right, let's do a sample problem. It says the area of the rectangle is 20 square meters. So the area is 20 meters squared. The altitude is 5. Now you might be saying, oh, well, shouldn't the altitude be here? Shouldn't that be 5? Honestly, it doesn't matter for a rectangle which one you call the base and which one you call the height, because if you were to take this rectangle and just sort of rotate it, there's your 5, so there's your height. So it really doesn't matter in a rectangle which one is the base, which one's the height, because every single time the edges meet, they make right angles. So any one of these sides could be considered the height. But now be very careful. I'm giving you the area, and I'm asking you to find the length of the base. So the formula is area is equal to base times height. Well, my area is 20 square meters. my base, let's call it x, and my height is 5. Bring my work over here. We're going to have 20 is equal to 5x. Divide by 5 on both sides, and we're going to get x is equal to 4. And that's the length of the base. Now, for x would equal 4 meters. It's not going to be meters squared. It's not going to be meters squared because the squared portion only comes in when you're finding the area. Now it's saying find the perimeter of a square whose diagonal is 10. Okay, so I'm not asking for area. Be very careful. So let's draw a picture. Here's my square. We know in a square all sides are congruent. It's saying the diagonal in the square is 10. We also know in a square all angles are right angles and that the diagonals bisect the angles. So we have two 45, 45, 90 triangles here. So I'm going to pull one of these 45, 45, 90s, and I know it's going to be x, x root 2. So my equation is x root 2 is equal to 10. Divide by root 2 on both sides, then rationalize. We are going to get x is equal to 10 root 2 over 2, which simplifies down to 5 root 2. So that means one of these sides is 5 root 2, which means all the sides are 5 root 2. Now I wasn't asking for the area, I'm asking for the perimeter. So the perimeter is going to be 5 root 2 plus 5 root 2 plus 5 root 2 plus 5 root 2, or 4 times 5 root 2, which is 20 root 2. Okay, for this next problem, we have two options here to find the area of the region. We can divide and conquer, or we can make, well, let's go through the divide and conquer first, and then I'll tell you the other method. So what I'm going to do to divide and conquer, I'm going to create little rectangles here. I'm going to make a little rectangles. I'm going to find the area of each rectangle, and then I will add all those areas together. Here we go. Okay, so here's my first rectangle. How do you find the area of a rectangle? Base times height. So 6 times 2 is going to give us 12. Now, we're going on to our next rectangle. Let's highlight that in blue. Now, the base of this blue rectangle is not 7. That 7 was initially given to us as this whole base. So now I need to find the base of the blue rectangle. Well, in the yellow rectangle, opposite sides are congruent. So I know this is 2, which means the base of the blue rectangle is going to be 7 minus 2. That gives us 5. So now we know the base is 5. The height is not 2. And let's go back to the yellow rectangle. In a rectangle, opposite sides are congruent. So this is 6, which means this whole height is 8. What does that tell us? It tells us the area is going to be 8 times 5, which is 40. Okay, let's keep going. Let's move on to a purple rectangle. Now we know the base is 2, that's clear. Now the height, just a little bit, the height is going to be 8 minus 5, which is 3. So the area is 3 times 2, which is 6. And finally, this total height is 8, the base is 3, the area is 24. So when we go ahead to add these all together, the area is going to be 12 plus 6 plus 40 plus 6. Oh, not 6, sorry. Let's go back. Erase, erase. I was looking at my numbers wrong. So the area, the yellow rectangle, the area is 12. The blue rectangle, the area was 40. The purple rectangle, the area was 6. The white rectangle, the area was 24. There we go. So the area is going to equal, if you add all of these up, it's going to be 82 units squared. And you could just put a U and then squared for units squared. Okay, so now I said there were two ways to do this. Let me show you the other way. Okay, so now the other way, instead of splitting these into little rectangles, what I'm going to do is I'm going to close this up and I'm going to make a really big rectangle. And after I make that really big rectangle, I'm going to find the area, and then I will subtract out the area of these little quadrilaterals. Okay, so let's figure this out. The base of this rectangle is not 7, it's not 3, it's not 7 plus 3. It is 12. 7 plus 2 plus 3, because in a rectangle, opposite sides are congruent. So if the top is 2, the bottom is 2. And the height is going to be 6 plus 2, which is 8. So the area is going to be base times height, which is 8 times 12, and that gives us an area of 96. Now that's not our final answer. Now what we want to do is we want to subtract out those holes, those yellow areas. So the area of the square is 4, the area of this rectangle is 10. So the area is going to be 96 minus 14, which gives us, once again, 82 squared. Okay, so it says the ratio of the base to the height of a rectangle is 5 to 6. If the perimeter is 110, find the area. So I'm going to draw my own diagram here. The ratio of the base to the height is 5 to 6. Now think back to Algebra 1. The minute you take numbers out of a ratio, you either put them into an equation or you put them in a diagram, you can no longer just leave it 5 to 6. You have to put a variable with it. So it's 5x to 6x. And we know in a rectangle, because it says it's a rectangle, opposite sides are congruent. So if the bottom's 5x, the top is 5x. If the right is 6x, the left is 6x. And now it's saying not the area, the perimeter is 110. So what does that mean? It means 5x plus 5x plus 6x plus 6x equals 110. This is going to give us 22x equals 110, and x will equal 5. Now that we know what x is, we can go back and plug in to find the dimensions. So 5 times 5 is 25, 6 times 5 is 30. So now it's saying find the area. Well, the area is easy. Area is base times height. So our area is going to be 30 times 25, which is going to give us 750 units squared. All right, let's keep going. Okay, a rectangular picture measures 12 by 30 centimeters. It is mounted in a frame 2 centimeters wide. Find the area of the frame. Okay, so this didn't come out very clearly. The 2 centimeters represents the distance from here to here and from here to here. That's what the 2 represents. So we want to find the area of the frame. When they're asking for the area of the frame, basically what I'm asking for is this yellow area right in here. Okay, so how am I going to find just the yellow area? I know we have two rectangles, but if I find the area, remember the area is the inside portion, right? If I find the area of the big rectangle, the area is going to be too big. And if I find the area of the smaller inside rectangle, that area is going to be too small. So how am I going to find the area of just the yellow region? We're going to find the area of the big rectangle and subtract from that the area of the small rectangle. All right, so the area of the small rectangle is going to be pretty easy to find. We know it's base times height, so we got 12 times 30. So the area of the small rectangle is going to be 360. There we go. All right, now we want to find the area of the big rectangle. The area of the big rectangle, well, it's also going to be base times height, but we got to figure out these dimensions. So the base, let's think about this. We know this is 30, but we know from the end of the small rectangle to the big one is another 2 centimeters and also another 2 centimeters on the left side. So the base of the big rectangle is not 30, it's not even 32, it's 34. And it's the same idea when we're finding the height. The height of the little rectangle is 12, but to get from the little rectangle to the big rectangle, we're going to add 2 to the top and 2 to the bottom. So the base, the height, not the area, the height of the big rectangle is going to be 12 plus 2 plus 2, which is 16. So the area of the big rectangle is going to be 34 times 16, which is going to give us 544. Now we're going to subtract these two areas. And we're going to get an area of 184 centimeters squared. Okay, so that's the end of 11.1, 11.2. We're going to keep going. I'm sorry, that's the end of 11.1. We're going to keep going on to 11.2. These are all formulas you should be pretty familiar with. So that's why we're going to be going through this fairly quickly. Next one is going to be a parallelogram. A parallelogram is going to actually have the same formula as the rectangle, where it's going to be base times height. Now, I can't stress this enough. A height always has to be made with a right angle. If it's not made with a right angle, it's not the height. So for example, we know a parallelogram is generally tilted, right? So even though we know this is the base, saying that's the height is wrong. A height has to make right angle. So we would have to drop down the altitude, and that would be the height. And to find the area of a triangle is going to be half times the base times the height, or base times height over 2. I think we're ready for some sample problems. So we want to find the area of each triangle. Well, look here. We have our height. How do I know we have our height? I know we have a height because it's making a right angle. And the height always connects to the base. So I'm going to say it again. The height always connects to the base. If you're trying to figure out which side is the base, it's whatever side the height connects to. So here, the area is going to be half base times height. Area is going to be half. My base is 15. My height is 10. Yeah, every year I say this and kids are shocked. Multiplication is commutative. So I don't have to take half of 15 and get 7.5 if you don't want. You could jump around. Instead of taking half of 15, I could say, well, what's half of 10? Half of 10 is 5. 5 times 15 is 75. And that's going to be centimeters squared. All right, the next one. Let me explain what these dashed lines are. These are not part of the triangle. This is showing you just the height. That's it. Now the base is still 7. Okay, the base is 7. This dashed lines are just showing you the height. So area is going to equal half base times height. So the area is going to equal half. My base is 7. My height is 8. Again, multiplication is commutative. You don't have to take half of 7. You could go ahead and take half of 8. And then we'll get 7 times 4, which is 28 millimeters squared. Now we're being asked to find the base of a triangle with an altitude of 15 and an area of 60. So this time I'm giving you the area and I'm asking you to find the base. They're saying the altitude is 15. Now remember, an altitude of a triangle makes a right angle. Altitudes make right angle. So essentially they're giving us the height and they're asking us to find the base. Well, since they're talking about area, I'm going to write down the area formula. Area equals half base times height. Now the area is 60, so instead of A, I'm going to substitute in that 60. Our base is X. It says find the base, right? So I'm going to call it X. And our height is 15. Now we're going to want to solve for X. So I'm going to start off by multiplying by 2 on both sides. So I'm going to get 120 is equal to 15X. I'm going to divide by 15 on both sides, and I will get X is equal to 8. All right, next one. Find the area of a parallelogram whose sides are 14 and 6 and whose acute angle is 60. All right, I'm going to start this one because this is definitely something that should pop up on one of your test quizzes. All right, find the area of a parallelogram whose sides are 14 and 6. Now I'm going to tell you, it does not matter which side you say is 14 and which side you say is 6. So I'm going to go ahead, I'm going to say this side is 14 and this side is 6. Now we know in a parallelogram, opposite sides are congruent, so I'll label those just to make you happy. Now it's saying an acute angle is 60. Okay, before I label the acute angle, we know area is equal to base times height. Find the area. So I know that's the formula I'm going to use. We also know a height has to be made with a right angle. I'm going to have to draw in an altitude here, and that's going to be my height. Now, I still need to label the 60 degrees. I'm going to go ahead and I'm going to choose to label that 60 degrees in this right triangle because it's going to help me find the height. Now, you have one of 2 locations to label that 60. You might want to say it's here, or the wrong answer would be up top. Why is up top the wrong answer for the 60? Well, it says one of the acute angles in the parallelogram. First of all, this angle right here is not the full angle of the parallelogram. This whole angle would be the full angle of a parallelogram. And you might say, oh, well, it looks like it's obtuse. It doesn't matter that it looks like it's obtuse because things aren't on to scale. But we need an angle inside the triangle. Not part of the angle inside the triangle, the full angle inside the triangle. So I'm going to go ahead and label my 60 here, which means this is a 30, 60, 90. I'm going to label my full 14 so we don't get confused. This is all 14. And now I need to find the height. Well, we know opposite the 30 is x, opposite the 90 is 2x, opposite the 60 is x root 3. So here's my equation. 2x is equal to 6, so x is equal to 3. So that means this portion of the base is 3 and our height is 3 root 3. We now have everything we need. So area is going to equal our base. Remember, the base is always the segment the height connects to. So where does the height connect to? The 14. And then my height is 3 root 3. So our area will be 42 root 3 units squared. All right, moving on to our very last page. Find the area of an isosceles triangle with sides 10, 10, and 16. Isosceles means two sides are congruent, so we're 10, 10, 16. Now the area is equal to half base times height. Well, you might be saying, okay, this is easy, half 16 times 10. Why is that wrong? That is a big no-no. Why is that wrong? Remember, a height has to be made with a right angle, and there's no right angle here. So what are we going to do? We are going to drop down an altitude. And when I drop down that altitude, these two triangles end up becoming congruent by hypotenuse leg, which means this 16 gets split into 2/8. And I can easily find the height by looking at one of these two triangles. We have an 8 and a 10. I'm going to take that triangle, I'm going to divide by 2. We have a 4 and a 5, which is a triple. A 3, 4, 5, go back, multiply by 2, and we get a 6 for our height. So now that I know the height is 6, I can go into my area and say area is equal to half. My full base is 16. My height is 6. Half of 16 is 8. 8 times 6 is 48 units squared. Hey, this next question is also a great question. A triangle has the same area as a 6 by 8 rectangle. The base of the triangle is 8. Find the altitude of the triangle. Okay, so I know I have a rectangle and I know I have a triangle. I'm going to make a right triangle so my altitude, so my side is also my altitude. They're saying the base of the triangle is 8. Find the altitude. I'm going to call it x. Now they're saying the area of this triangle is the same as the area of the rectangle, which is 8. Well, the area of the rectangle is base times height, which is 48, which means the area of the triangle is also 48. So now I know area is equal to half the base times height. So the area is going to equal half, the area is equal to half the base times the height. Now the area we know is the same as the rectangle, so it's 48. I'm going to substitute in that 48. 48 is equal to half. My base is 8 and my height is x. I'm going to go ahead, I'm going to take half of 8, which is 4. So 48 is equal to 4x. Divide by 4, x is equal to 12. And our very last question, find the area of an equilateral triangle with a perimeter of 30. So let's think about this. Equilateral means all sides are congruent. So if the perimeter is 30, we know each side is 10. Area is equal to half the base times the height. Now, what would be really help us to know or to remember is that if a triangle is equilateral, it's also equiangular, which means all these angles are congruent, which means each angle is 60. Now, remember, a height is made by a right angle, so a segment that makes a right angle. So I'm going to drop down my altitude. When I drop down my altitude, these two triangles end up becoming congruent. So this is 5, this is 5, the whole base is 10. And that top angle gets split into two 30s. So we are dealing with a 30, 60, 90 triangle. Opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x. So we know opposite the 30 is x, so x is 5, the height is 5 root 3. So the area is equal to half. My base is not 5, my whole base is 10, and our height is 5 root 3. Half of 10 is 5. 5 times 5 root 3 is 25 root 3 meters squared. Okay, we are done for today. Have a great day.